Today's exercise is exercise number 11. This is on to find RL of top of the object when base is inaccessible. In my previous class we have discussed on base accessible, but here to find the RL of top of the object when base of the object is inaccessible. What is meant by inaccessible? Inaccessible base is the base where we can't go and reach because of the ground conditions. If there is a thick forest here, you can't do leveling survey. You can't go to that base. When we can't able to go to the base, we call such exercise as base inaccessible. Now, how to find RL of top of the object when the base is inaccessible, that we will discuss in today's class. Right? Now, how to conduct this exercise? This is the given object. The object may be an electric tower, or it may be a chimney, or it may be a building, top of the building, any type. It's a generalized. So here I have taken an object as an electric tower. Need not be always electric tower, it may be any of this type. Flag post, it may be a flag post, or it may be top of the building, anything. Right? Now first what you are supposed to do is select a convenient ground, and at that particular point select station A, right? At that station A, set the theodolite over the station A and do all temporary adjustments. You know what are the temporary adjustments to be made? So leveling, first we have to do the centering, we have to do the leveling, and then removing the parallax, focusing. All those temporary adjustments you have to do over the station A. After making all the temporary adjustments over the station A, bring the vertical angle 0 degree, 0 minutes, 0 seconds. After making the vertical angle 0 degree, 0 minutes, 0 seconds, now the instrument is horizontal. That is, line of axis is horizontal. Now place the staff over the given benchmark. This is the benchmark given. Right? Place the staff over the given benchmark and take the staff reading. Let the staff reading be S1. Let the staff reading station taken from the station A be S1. Note down that staff reading S1. Then bisect the top of the object which you have to find the RL. Bisect station point. Let us take the station point as C. Okay, top of the tower. Let us take the top of the tower station as C. Bisect that C station. Let the angle, note down the vertical angle. After bisecting the station C, note down the vertical angle. Let this vertical angle be alpha 1. Now the alpha 1 is the vertical angle from station A. Now what are the observations we are going to make from station A? Following are the observations you are going to make from station A, that is staff reading over the benchmark S1 and the vertical angle alpha 1. This is what the observations we are going to make over the station A. Right? Now this method is single plane method. There are two methods to find the RL of the top of the object when base is inaccessible, single plane method and double plane method. We are following single plane method. So how we are going to carry out in single plane method? After making all the observations from station A, we have made all the observations from station A. Now we have to select the station B. We have to select station B along the same line of AC. Along the same plane, you have to select another point, station B. Now, how to select the station B along the same line? To select the station point B, so first what we have done are from instrument A. So, we have a station at instrument A. So, from instrument A, at the station A, bisect station C and plunge the telescope. Reverse the line of sight of the telescope, because A, C and B all should be in the same plane. When A, C and B all should be in the same plane, first what you have to do is bisect station C, right, and then plunge the telescope, reverse the line of sight of the telescope. When you reverse the line of sight of the telescope, the line of sight will be in opposite direction. Along this line of sight, select station point B at a convenient distance, right? Let the convenient distance from A and B, let us take this distance as D. This D distance may be 10 meter, 15 meter or 20 meter. Select this distance, measure this distance D at a 10 meter or 15 meter, right? Depends on the field conditions. So, after selecting the station point B, so you should note down that A station, B station and C station all should be in the same line, right? So, select station B at a convenient distance D from A. So, after selecting the station B, now shift the theodolite over station B, right? Now, shift the theodolite over station B. After shifting the theodolite over station B, once again make the vertical angle 0 degree, 0 minutes, 0 seconds. Right? Make the vertical angle 0 degree, 0 minutes, 0 seconds. Then line of sight will be horizontal. Now place the staff over the benchmark and take the staff reading from B. So from station B, once again take the staff reading. Let the staff reading station from station B be S2. S2 is the staff reading taken from station B. Understood? S1 is the staff readings taken from station A. S2 is the staff reading taken from station B. After taking the staff reading S2, now bisect station C and note down the angle. Bisect station C and note down the angle. Let this angle be alpha 2. Right? Alpha 2. Alpha 2 is the angle which is measured from station B. Note down these observations. Alpha 1, alpha 2, D distance, S1, S2 in the field. Right? Now, after noting down all these distances, how to find RL of the station C? From these observations. Let us take this distance as H1. Let us take this distance as H2. And the distance between, the horizontal distance between A and the object, let us take this as capital D. Now we have to find out this D, we have to find out this H1 and we have to find out this H2. This horizontal distance D between the object and the station A, we can find out using the formula. The formula for finding out this horizontal distance D is given by D is equal to D tan alpha 2 plus or minus S divided by tan alpha 1 minus tan alpha 2. What is this D? D is the distance between the two stations A and B. This is D. Alpha 1, alpha 2 are the angles of elevations from station A and station B towards the station C. And what about this S? S is equal to difference between the staff reading. S1 minus S2. This is S. Here we have plus or minus sign. When we are using the plus sign and when we are using the minus sign. Plus sign we are using when A is lower than B. Minus sign we are using when A is higher than B. Right? So, the plus and minus sign we have to use based on the field conditions which we have. Sometimes A may be higher, sometimes B may be higher. Right? So, field conditions we have to see, and based on the field conditions we have to find out this, we have to take positive or negative sign. So, this is how the S is calculated. After finding the value of D, now we can find out the value of H1 and H2. Now, how do you find out this H1? To get the value of this H1, consider this triangle. This will become A dash, C, C1 dash, this will be C2 dash. Now, consider this triangle A, C, C1 dash. This is alpha, this is H1, this is D. This distance is D, this is H1, this is alpha. Now consider this triangle AC D1 dash, C1 dash. H1 is equal to D, this is alpha 1. This angle is alpha 1, D tan alpha 1 is the value of H1. Now consider another triangle. Let us take this as a B dash, C, C2 dash, B dash, C, C2 dash. Now this angle will be alpha 2, this angle will be alpha 2, consider this triangle, and this distance will be D plus D. Now this distance is D, this distance is capital D, therefore this horizontal distance B dash C2 dash is D plus D. Let us take this as H2. Then the value of H2 will be equal to D plus D tan alpha 2. This is H2. So find out these values. Find out the value of D, find out the value of S. First find out the value of S, and then that S value you have to substitute here to get the value of D. After finding D, find out the H1 and H2 using these two formulas. After finding H1 and H2, you can find out RL of C. RL of C is equal to RL of C is equal to RL of benchmark plus S1, RL of benchmark plus S1, that gives you line of axis, horizontal axis from A, plus S1 plus H1. So here RL of C is equal to RL of benchmark plus S1 plus H1. RL of C is also equal to RL of C is also equal to RL of benchmark. So here RL of benchmark plus S2 plus H2. Now both the values RL of C from A and RL of C from B both should be same. There is a verification whether you have done it correctly or not. Right? So this is all we are going to calculate or find the value of RL of C point. Now let us go to field and perform this exercise, and we will come back and we will do the calculations. Okay? Now we will go to field. This is an exercise on finding the RL of top of the inaccessible point. Okay? Top of an object when base is inaccessible. Now here this is the water tank. You can see the water tank. The top of the water tank, that is the yellow one, the plastic water tank, PVC water tank which I am shown there, that is the top. That RL of the top I have to find. Now I can't reach the base there. I can't able to go that particular place. because of obstruction, right? I can't measure the horizontal distance d from that particular point. So, this is a case of base inaccessible, where we can't go and reach the base, right? Now, my object of today's exercise is to find the RL of top of the water tank, that is PVC water tank, with respect to the given benchmark. The benchmark is given here. This is the benchmark. The benchmark is this is the given benchmark. The given benchmark is 880.225. This is the benchmark. With respect to this benchmark, I want to find the RL of top of the object. Okay. So, this is the aim of the today's exercise. The first step, make the vertical angle, bring the vertical angle to 0 degree, 0 minutes, 0 seconds, right. The vernier C and vernier D, both should be 0 degree, 0 minutes, 0 seconds. 0 of the vernier and 0 of the main scale, both should coincide. Okay. This is 0 of the main scale and 0 of the vernier, both should coincide. For finer adjustment, okay, now this is 0 degree, 0 minutes, 0 seconds. Here also it is 0 degree, 0 minutes, 0 seconds. 0 of the main scale and 0 of the vernier is coincided, and now it is horizontal. Now the axis is horizontal. So, at station A, the axis is horizontal and we have to take the staff reading from station A. Now, let us place the staff over the station A and take the staff reading. This is the staff reading from station A. The staff reading from station A, that is S1, is 1.050. The staff reading S1 is equal to 1.050 meter, right. After taking the staff reading from station A, now let us bisect the station C, okay. Let us bisect the station C and then measure the vertical angle alpha 1. The top of the water tank, and I am going to note down the angle alpha 1. You are going to find the main scale reading and vernier scale reading. The main scale reading is 8 degree 20 minutes. 8 degree 20 minutes is the main scale reading. MSR reading is 8 degree 20 minutes. Next, VSR reading, vernier scale coinciding vernier scale reading. Coinciding vernier scale reading is 5 minutes 20 seconds. Therefore, the angle is 8 degree 25 minutes 20 seconds. 8 degrees 25 minutes 20 seconds is alpha 1. Now, we got alpha 1, we got S1 from the station A. 2 readings we have found out. So, after finding this A, that is S1 and alpha 1, I want to select the another station B in the same line, that is station A, station C and station B. All these 3 lines should be in the same line. To select the station B, what I am doing is, I am plunging the telescope. I am going to reverse the line of sight because all the 3 should be in the same line. I will reverse the line of sight and I will select another station B along the same line at a convenient distance. Okay. So, let us take the station C, select the station B at a convenient distance. Okay. Now, this is a point, this is the station, So this is station B. Now the distance between A and B is 13 meter. That is small d is 13 meter is the distance between the station A and station B. Now the station A, station B and station C all in the all the three is in the same line. Hence this is called a single plane method. This is called single plane method. So after completing the observations from station A, we have to shift the instrument to station B. We have to shift the instrument to station B and then we have to take the readings. Now we have to do the centering. All temporary adjustments you have to make over the station B. The centering, leveling and focusing. All the three temporary adjustments you have to do over the station B. Okay. Now leveling is done, centering is done and leveling is done. Now I want to make the vertical angle once again 0 degree, 0 minutes, 0 second. Bring the vertical angle 0 degrees. See that vertical angle is 0 degree. Yes, it is 0 degree. Now the staff reading is 0.980. Is the staff reading. Let us find out the angle alpha 2. Tight both the clamp screws and note down the vertical angle alpha 2. Now the angle is 6 degree 20 minutes. Six degree 20 minutes is the main scale reading and the vernier scale reading is 2 minutes 40 seconds. 6 degree 22 minutes 40 seconds is the angle alpha 2. Now we have made the observations from station B, the staff reading we have taken and angle alpha 2 we have taken. So these are the observations we have made in the field. After making all these field observations, then we have to do the calculation. After making all the field observations, let us do the calculations. Now at the field, the staff reading from the station A, S1 is 1.050 meter and staff reading and alpha 1, the vertical angle alpha 1 is 8 degree 25 minutes 20 seconds. This is the observations done from station A. And observations done from station B, that is S2 is equal to 0.980 and alpha 2 is equal to 6 degree 22 minutes 40 seconds. Now the difference between the staff reading S is given by S1 minus S2, which is 1.050 minus 0.980. The value of S is equal to 0.070 meter. This is the value of S. Understood? Now D, the distance between station A and B is equal to 13 meter. All this data we have obtained from the field. Now let us use this data and let us substitute this data for finding the horizontal distance D. If you see here, the staff reading at S1 is higher than the staff reading at S2. S1 is greater than S2. When the station A, that means station A is higher, station B is lower. When station A is higher, station B is lower, for finding horizontal distance D tan alpha 2 plus or minus S divided by tan alpha 1 minus tan alpha 2, we have the formula. In this formula, we are going to use minus sign because the station A is higher than station B. Hence, we are going to use the minus sign. D is the distance between the station A and B. Alpha 2 is the angle measured from station B. S is the difference between the staff reading, S1 and S2. And alpha 1 is the angle measured from station A. Let us substitute all these values and find the value of D. The small d is 13 into tan alpha 2, that is 6 degree, 22 minutes, 40 seconds, minus S 0.070, whole thing divided by tan alpha 1, that is tan alpha 1 is 8 degree, 25 minutes, 20 seconds, minus tan 6 degree, 22 minutes, 40 seconds. Therefore, the horizontal distance D is equal to 37.58 meter. This is the distance between A and the object. The D is 37.58 meter. Now we have found out this distance D. Now we have to find out this H1 and H2. H1 is equal to D tan alpha 1. Therefore, H1 is equal to D is 37.58 into tan alpha 1. Tan 8 degree, 25 minutes, 20 seconds. Therefore, the value of H1 will be equal to 5.564 meter. Similarly, H2 is equal to D plus D tan alpha 2. That is, D plus D is 13 plus 37.58 into tan alpha 2, that is 6 degree, 22 minutes, 40 seconds. Now let us find out the value of H2. H1 already we know. Find out the value of H2. If you simplify this, the value of H2 is 5.653 meter. 5.653 meter. Now I want to find out the RL of C. RL of C. RL of C is equal to RL of benchmark plus S1 plus H1. RL of benchmark plus S1 plus H1. Therefore, RL of C is equal to, now the RL of benchmark is 880.225. This is from the field. That is 880.225 plus S1. S1 is 1.050 plus H1 5.564. Okay, plus 5.564. The value is RL of C is equal to 886.839 meter. This is the observations from A. Similarly, observation from from B. RL of benchmark plus S2 plus H2. Let us find out the value. Now, RL of benchmark is 880.225 plus S1. S1 is, S2. S2 is 0.980 plus H2. H2 is 5.653. Now, RL of C is equal to 886.864 meter. So if you observe RL of C 886.839, 880.864. This is the reading which we got from. This is the reading for RL of C. Okay. This is how we are going to find the RL of the inaccessible point.